Hi everyone, welcome back to Prieto TV and welcome to the new episode of Prietology. So if you remember from our last episode, we talked about the basics of elements like atoms, molecules, ions, isotopes. Today we're going to take that a little step further and going more into chemicals and what makes them different. So today's lesson is about acids and bases. Okay, so as you see today, we only have four key terms. We have acid, base, pH, and universal indicator. So, like I said, also today we will be talking about acids and bases. So let's start with acid. Okay, so our first term is acid. Acids are chemicals with a low pH. We're going to talk about pH later. And usually acids are a donor of positive hydrogen ions. We learned what ions are last time. So when you put an acid like, let me give you an example. Vinegar. Vinegar is a really good example of an acid. Also, lemon juice. Lemon juice is a good example of an acid as well. These contain lemon juice, which is an acid. So when you put them in water, they disassociate and breaks into the acid. The acid breaks the water into positive hydrogen ions and positive hydrogen ions and negative hydroxide ions. I'll talk about what those are later. And when associated with the pH scale, they are 0 to 7 on the pH scale, which usually is involved with the universal indicator. So usually acids that are weak are very corrosive. An example of a weak and corrosive acid is methane acid, and usually strong acids are sometimes mild. An example of a strong acid is carborane superacid. Usually weaker acids are higher near the 7 range, and stronger acids are usually near the 0 range. Okay, so our next key term is base. Bases and acids are like polar opposites. They're completely different. Bases, unlike acids, have a high pH. Acids have a low pH. And also, bases are donors of negative hydroxide ions, which are just negative and then OH ion. And then while acids are donors of positive hydrogen ion. And usually the most common bases are called alkalis. Bases usually make up the alkali metals and alkaline metals, which you discussed in the first episode of Prietology. And the third thing is that there are 7 to 14 on the pH scale, so they're the higher half of the pH scale. Acids are the lower half of the pH scale. One of the strongest base I think out there is sodium hydroxide. They have the ability to melt fat and unclog drains. And I'm not sure about the weakest base out there, but the weakest base out there, one of the weakest ones is ammonia. I'm pretty sure you've heard of ammonia. Ammonia is used in metal cleaners like this. This contains ammonia, right? Yes. And another example of a base that you probably have in your house is soap. Soap is a really good example of a base. It's probably all around your house. Okay, so the next term. Who is this? Hi, I'm secretly tuning into your lesson because I hacked your network. Oh, okay. Well, why would you do that? That's just my only question. I called you because I have a question from your lesson. Okay, well, what's your question? Okay, so the question is, how are acids and bases related? Okay, well, that's actually a really good question. Let me explain. Well, as you guys heard, this hacker guy asked, how are acids and bases related? So basically, it all starts with water. I'm going to draw my cartoony water molecule here. I'm sorry that I wasn't able to get my model atom because we didn't need him for today. Okay, so like I said, positive water molecules. So when acids like to give away the positive hydrogen ions, and the bases like to give away the negative hydroxide ions. So positive hydrogen, like when it's an ion, is also positive here. And when it's negative, it's negative OH, hydroxide, hydrogen. So acids and bases, when you put if you put one in water, so let's say you put an acid in water or a base in water, the acids are going to take away the hydrogen, and the bases are going to take away the hydrogen, and the acids are going to take away the hydroxide. So this would belong to the bases and this would belong to the acids. As we learned last time, ions are molecules that have gained or lost an electron. So since these have lost one, since these are losing their electron, they become ionized. And so somehow they would probably combine back because, well, opposites attract because of electricity. So like I said, the acids take the negative hydroxide and the bases take the positive hydrogen. Oh, great, thanks. Also, you wouldn't mind telling me your social security number, would you? Well, of course not. Are you sure? I'm positive. Are you absolutely... Some people are a bother. Okay, so our next term, before I got interrupted, our next term is pH. pH measures how acidic or how many positive hydrogen ions there are in a chemical. So, like I said, it ranks from 0 to 14. Low numbers, 0 to 7, are acidic. 7 through 14 are the high numbers, and those are considered basic. But, David, what about the 7 in the middle? Well, the 7 both counts for acidic and basic. 7 is neutral. That is a neutral range. I think there's one chemical that is in the 7. I think it's water. Water, pure distilled water is 7, which is neutral. So usually in the pH, the more hydrogen ions, the more positive hydrogen ions there are, the more acidic it is. And the pH is it's essential to body and ocean chemistry. Okay, the last term that we will discuss is the universal indicator. So the universal indicator is, I think you've seen this before. This is in the book, the Big Book of Science Experiments. I leave the link in the description below. The pH scale, I think we can get this on the camera. The pH scale is like the universal indicator is like this. Red, it's a color changing scale to determine how acidic or basic something is. Just like the pH, it is measured from 0 to 14, and like I said, it lets you know how acidic or how basic something is by color. So usually, like I showed you in the book, the redder it is, the more acidic it is. If it's green, the more greener it is, the more neutral it is, around that 7. And the more purple it is, the more basic it is. And I think you've seen before, they usually come in little paper strips. These are to test for pH in pool, and these are actually universal indicators. Well, one of them is one of the colors is pH. Like, do you see this row is pH, and if you see it says OK right there, where it's supposed to be good, like around the 7 range. So let's go. Now we're gonna actually go test the pH. Okay, so here I have my little universal indicator, and here is my pool. So the instructions say to dip it in for like 15 seconds, right?
I think.
Okay, so I'm just gonna dip it in and leave it for 15 seconds. Okay, 15 seconds are up, and as you see here, it changed colors. This orange is the pH. So let's go back inside and measure it. Okay, so we took in the pH of my pool, and this is this is starting to get a little red. It's between 6.2 and 6.8 pH. So that means this is slightly less acidic than it's supposed to be. Well, I think we covered all the key terms for today, so let's get on to experiment of the day. Okay everyone, this is experiment of the day. Today's experiment, like we said about acids and bases, it's called lemon chemistry. So what you'll need some fresh lemons, a knife, a small measuring cup, and a small measuring spoon. It has to be a tablespoon, and baking soda, some liquid dish soap, and a clear cup for the reaction. Okay, the first step is that we have to roll the lemons just to get the juice out of it. So I'm just gonna move everything over here. Okay, let's roll them just like it says to roll on a table like dough. So this just releases the juice inside the lemons. So when we cut it, it'll have a lot of juice inside. So this one. Okay, so now we need the small measuring cup and a knife. So gotta be careful. And then we just cut the lemon in half. So is that the sharp side? No, this is the sharp side. Now, which way is the sharp side?
It smells like lemons.
It does. Is this way the sharp side? Yeah, that's the sharp side. So just cut our lemon open. just squeeze out the juice. So I don't think so. So maybe you're probably gonna have to remove the seeds as well. As you can see, since we rolled the lemon, it activated all the juice that was inside. So okay, that's our lemon, and then let me just give this another quick roll. Cut the lemon open. Just want to cut my fingers. There we go. Pretty juicy inside. And then there we go. We got our lemons, and then we don't need the knife anymore. Okay, and then in our empty glass, we add 1 tablespoon of baking soda. So is this 1 tablespoon? That's about a tablespoon. Is it in the camera? Mm-hmm. Okay, so we just add 1 tablespoon. And then add 1 teaspoon of liquid dish soap. I'm gonna go get a teaspoon really quick. Okay, got the teaspoon. So we take 1 teaspoon of liquid dish soap. A little more. There we go, that's our teaspoon. And then we just pour it to the baking soda. And you can just stir it up a bit. So, okay, that is starting to look like baking soda and soap combined. Kind of looks like snow. Oh well, we can put that aside. Now for the reaction. I'm gonna try to get a close angle. So what will happen, what's supposed to happen is that when I pour the lemon juice inside, which is an acid, it'll react with the bases, which is baking soda and soap, and it should make like little bubbles and carbon dioxide. So let's see what happens. There we go, look at that. They are reacting to form some carbon dioxide. As you can see, oh boy, this is getting full really fast. Oh boy, oh mackerel.
Put more in.
Okay, no, it's overflowing. It's overflowing. Now I could just put more in. You want me to put more in?
Yes.
Oh gosh.
I want to make this because I'm that type of person.
There we go. Oh gosh. So as you can see, the lemon juice is reacting a lot with the baking soda. So you might be wondering what is happening. The acid, which is our lemon juice, is reacting with our bases, which are the baking soda and the soap. When an acid and a base combine, they make bubbles and they form carbon dioxide gas. The liquid soap, when you add it to water, it makes bubbles and foam. So when you add the lemon juice and the baking soda to the soap, it forms bubbles and foam that erupt right out of the glass. So like I said, we covered all our key terms for today. And so our next class is going to be about chemical reactions. I'm excited for that one. So thank you for watching. Like, share, and subscribe. Get this video to the front page, and I'll see you later.